Hello, my name is Bob, and I'm a tutor at Raritan Valley Community College's Academic Support Center. This is Session 4 on GeoGebra, and this is Module 8. We're going to talk about composite functions. In this module, we're going to demonstrate composite functions using GeoGebra. We'll look at f plus g of x, f minus g of x, f times g of x, f divided by g of x, f of g of x, and we'll look at inverse functions. So let's get started. And what we're going to do is I'm going to double click on our GeoGebra icon and get it launched. And we're going to go up here to options, and we're going to turn our font size up to 18 to make it fairly easy to see. So let's load in our first function. Let's have function f of x be equal to 2x plus 1. Alright, and let's have our function g of x be equal to x squared, x up arrow 2, plus 2x plus 1. And I always mistype the plus sign. Let's go back in and fix that and hit enter. So there are two functions. Well, a composite function puts those two functions together. So if we wanted to look at f plus g of x, let's turn these off so we can hide them. Oops, I dragged that one around. I didn't want to do that. There it is, back where it started. Let's do a right click up here, and let's just turn that object off by right clicking on it and then turning it off, and then right click where it says show object. We're going to left click on that. And now let's define a new function, h of x equal to f of x plus g of x, and hit enter. And now you can see our curve is the composite of those two functions. We could also do f of x minus g of x. We'll define I of x is equal to f of x minus g of x. And again, there's a case where we've got the composite of the two functions right along that line. Remember, if we show that line, we can go up and show that line if we want to. You can see how they're touching right along that line there. Let's get rid of that line again. We're going to do a right click on it and turn it off. And let's get rid of these two objects. We're going to delete the first one, and we'll go in and delete the second one. We can also look at the multiplication of two functions or the division of two functions. Let's look at f of x times g of x. Let's define function h of x equal to f of x times g of x. And now you can see I get a cubic equation that's the multiplication of those two equations. I can define I of x, paren x paren, as equal to, let's do f of x divided by g of x. And now you can see I get this equation. Let's hide that other one. Turn it off so you can see that equation more clearly. And we can zoom in on it or zoom out if we want to see it a little bit better. We can also do the composite of two equations. We could do f of g of x. Let's do that. Let's get rid of h of x and I of x. I'm going to right click on them and delete them. And I'm going to do I'm going to do h of x equals f of g of x. And I need two closing parentheses and hit enter. And there's f of g of x. Okay? And I'm going to grab this line just so you can see that it really is 2 times, in parentheses, x squared plus 2x plus 1.06 plus 1. And the other one is, we could do it the other way. I could do I of x is equal to g of f of x paren paren. And it's a slightly different function. In this case, let's hide that first one. In this case, you can see it's 2x plus 1 squared plus 2 times 2x plus 1. And let's move this out just a little further, times 1.06. So we're able to do that using the composition of functions. Now the reason composition of functions is important is that one of the tests to see if a function is an inverse of another function is to see if f of g of x equals x. So let's try two new functions. Let's start with a new window. We're going to File, New, and we don't want to save this. And I'll move that bar back over. And let's, for our first function, use f of x is equal to, and this time I'm going to use 2x cubed, so 2x, I'm going to go down here and use the cube function because there is one, alright, minus 1, alright, and there's that function, and now I'm going to use g of x, it's going to be g of x is equal to, and in this case I want paren x plus 1, closing paren, divided by 2, closing paren, raised to the 1/3 power. So up arrow, paren, 1 divided by 3, closing paren. There's the other curve. The question is, are these two curves inverses of each other? Well, the test is, let's see what f of g of x is. So I'm going to define this h as being of x as being equal to f of g of x, paren. And there's my line y equals x. So in fact, using that test, it is an inverse. But we should test both ways. Let's hide that line. And we're going to go the other way, and we're going to do g of f of x. So we're going to take I of x is equal to g of f of x, paren, and we get the same diagonal line. So in fact, these are true inverses of each other. So now let's review what we looked at in this module. We demonstrated the composition of functions using GeoGebra. We looked at f plus g of x, we looked at f minus g of x, we looked at f times g of x, we looked at f divided by g of x, and we looked at f of g of x. And we learned how we could use f of g of x to demonstrate that two functions were in fact inverses of each other. This concludes this module.